Okay, well, welcome to ATG, the podcast. And I'm very pleased to have today the chance to talk to Elisabeth Bik, who's one of the best-known investigators into scientific malpractice. Elisabeth is a PhD microbiologist, but is better known today for identifying issues with more than 7,000 scientific papers and with over 1,000 retractions. She's been featured in national newspapers such as the New York Times and the Guardian, and she was awarded the 2021 John Maddox Prize for her work in science communication for an exposing research misconduct. So, good to talk to you, Elisabeth.
Great to be here, Michael. Lovely. Good morning from California, where I sit. It's quite a time difference.
Yeah, absolutely. Tell me, how did you become a scientist in the first place?
Well, I guess I always wanted to be a biologist. So when I was, I think, 10 years old or so in elementary school, people asked everybody, the teacher asked, what do you want to become? And, the boys wanted to become fireman or think pilots or so. And the girls maybe wanted to become, this is like we're talking about the 1970s. So pretty stereotypical, but maybe a nurse. But I wanted to become a biologist. So I was already the way run out. And I stuck to my plan and studied biology. And initially, I liked birds or so that was what I thought I was going to do for the rest of my life. But then I really liked bacteria. And so I liked my microbiology teacher very much, and I liked the classes. And I just stayed. I loved lab work, so I did internships in labs, really loved that, and then stuck in one of the labs at the Dutch National Institute for Health, and did my PhD there.
So your PhD was on, I believe, cholera, which doesn't sound the most enticing of subjects to spend years of your life studying.
No, it's a very it's a haunting topic. It's if you read about cholera and what it can cause and how horrible the disease is, it's quite something that will stay with you for the rest of your life if you read those descriptions of patients dying. And cholera also is not a disease that is really present in the Netherlands, where I was at that time. But it was just a topic, a research project that the person who became then my mentor, my PhD supervisor, wrote, and it was approved. And he said, I think you're the perfect person for it. Do you want to, do your PhD on that? And it was about developing a vaccine for cholera, which we thought was a good thing because we were working at the institute that made all the vaccines for the Netherlands. So, but it turned out, of course, a little bit different. My topic, the vaccine part of my PhD thesis, didn't work out. That was I could not reproduce somebody else's results, and that was quite frustrating. But luckily, another topic related to cholera came along, and I had much more success there and finished my PhD in that topic.
So that's very interesting. So you found lack of reproducibility actually sort of made quite a difference to you.
It was very frustrating trying. You see somebody else's, results, and I did exactly what that person before me did, and one day it worked, and this next day it didn't work, but I had to do 10 replicates or so, and it was just all over the map. And I said, I'm not quite sure what I do wrong because I do it exactly the same thing. So there must be something very finicky that maybe it works on a Tuesday but not on a Monday. You're just starting to believe in all kinds of voodoo, of course, but it didn't. I could not reproduce it. So that was one of those points in your PhD where you're just ready to give up everything because it didn't work.
I can imagine. Yeah. So you then worked with microbiomes, and for the benefit of non-technical people like myself, can you tell me what a microbiome is?
Yeah, and that was when I moved to the US and started working at Stanford. A microbiome is a group of organisms, like an ecosystem, that lives at a particular place. So usually we refer to the human microbiome, so the bacteria that live in our bodies, in our mouths, on our skin, in our stomachs, in our guts. That's where most of them live. And they help you digest your food, and they do some wonderful things. They can also, if there's a bad bacteria or a bad virus in there, they can make you sick. But it's like a forest. It's an ecosystem of different species. And we still know very little about them because it's not just one species that lives in our gut. There's probably thousands of them, and each of us has a unique collection of these bacteria and viruses and archaea, and some yeasts in there. So it's a very complex situation, and each of these species has their own little biochemical factories in them. They can convert certain molecules into others. So depending on which bacteria you carry, you might be able to convert, let's say, a particular drug into a drug that is actually more active or less active. So it might be the microbiome that we carry and its uniqueness might be partially explaining why certain drugs don't work in a person but work in the other person, or why certain foods are maybe not going down well, and we're still learning lots about it, but it's a fascinating topic.
So you spent 15 years at Stanford, and this is working with microbiomes. So why leave after that time?
Because I saw a job advertisement for a scientific editor at a very new startup company called Ubiome. And it didn't end well, Ubiome, but at that time it was a nice startup. And after working 15 years at a particular place, I just felt I couldn't grow anymore there. At Stanford, or at any university, I guess, in the US, you have a professor and then you have the people working in their group. And I just couldn't, I felt I wasn't learning anything more. And also the topic changed a little bit more from less lab work and more bioinformatics work, which I just was never trained in. So I felt very uncomfortable I was trying to learn it, but I just felt I didn't have enough background to really enjoy using it. So, I wasn't a Unix guru or so. So you run into all these issues where your computer just says, no, error, and I just couldn't do that. I really liked doing the lab work, but that was less and less of it. I saw this job advertisement, and I really had started to enjoy scientific writing, peer review. I also was looking already at shoddy, like bad papers, and so the whole process about scientific editing and publishing became a little bit more interesting. And it was a job at a microbiome startup, and so. And there was, a nice salary involved, much better than what I earned at Stanford. And what was not to like? And I got the job, and I really liked the first year. The second year, the company was starting to do some shady stuff with insurances and prescriptions. And so I left. And at some months after I left, the company got raided by the FBI. Quite something. They confiscated all the computers and of course never recovered from that. And the founders fled to Europe apparently, and from the US. This was in San Francisco, and they were charged with or at least indicted. And I'm not a lawyer, so I don't know the difference. But they were indicted with all kinds of insurance fraud and money embezzlement, so all kinds of bad things. But I worked there, so I still had fun, and yeah.
So when did you mentioned you've already had exposure to to research, well, I don't know if you can call it research misconduct, but non-replicability, but is that something that started to develop during your time at Stanford, or when?
Yeah, it was during still my 15 years at Stanford that I came across a paper that had plagiarized one of my papers. So I had written this review article on the human microbiome, my topic of interest. And I heard about plagiarism, and I sort of had a vague concept of what it was. But I thought, let's just take a sentence from my review article and put it in between quotes in Google Scholar, and probably nothing will come up, right? But something else came up, something that was not my paper, but somebody else's paper, that turned out that these authors had stolen several sentences from me, but also from other scientists, and sort of made this patchwork of this Frankenstein monster of different paragraphs. And so that made me so mad that I started to work on plagiarism as a hobby. I just started to find other plagiarized articles. Now, this was back in this was 2013. So I'm finding all these articles from 2006 or so, before most journals and publishers were starting to screen for plagiarism. So I was finding all these old plagiarized articles. But then one day, another coincidence, I found a PhD thesis with plagiarized text, but also
Gosh.
an image that had been duplicated. And I recognized that. And it was a Western blot, a bit of a technical term. But it had basically, it looked like horizontal stripes, 4 horizontal stripes with a little dot in the top right corner. And then a couple of pages later, I'm like, hey, there's that same photo again, except now it's a mirror image. So now the dot is on the top left, but it's the same photo. And I recognized it. And it was used to represent a different experiment. So that was bad. And then I switched, because I switched from plagiarism searching for these duplicated images.
Tell us a bit more about the wonderfully named Western blot, because that seems to be quite a central part of your work on image manipulation. What is a Western blot?
What is a Western blot? Well, how long do we have? It's a way to determine how much of a particular protein is present in a biological sample. So let's say you're testing mice and you're treating them with your drug, and you have your placebo group. So you have 2 groups of mice, the one that was treated and one that was not treated. But you want to see how the treatment of the drug affects the expression, or let's say roughly the quantity of a particular protein. So that's when you use a Western blot. So in a Western blot, you run first your soup of proteins. Let's say it's a serum sample or a liver sample from these mice, and you homogenize that and you run it in an electrical field. So all the proteins will separate like a barcode according to their the weight or the height or the length of the molecule. And so first you separate them like that. So it turns out it looks then sort of like a barcode with different proteins all in a row. And then you transfer that gel to a membrane and you incubate it with a particular antibody to just search for your one protein that you're interested in that big soup. So now you only visualize of that whole barcode, you only visualize one of the bands. And so it starts to look, the outcome is a film, and it starts to look like it will look like horizontal stripes, dark horizontal stripes on a white or light gray background. But basically, if you didn't understand anything about this, that's totally fine. It will become a photo, and the photo will be the photo of that Western blot will show let's say your 5 treated mice and your 5 untreated mice, and then just that one stripe, that one little horizontal band that is the protein of interest. And so it's a photo in a scientific article. And very often I find that there's problems with these photos. Sometimes photos are reused to represent another experiment, like the one I initially found, or they are rotated, mirrored, stretched, and are representing different experiments, or they're even photoshopped, where one of those horizontal stripes is photoshopped a couple of times. So it basically looks like a photo of a dinner party to me, where you see the same Uncle John is sitting both on the left side of the table, but you also see his face on the right side of the table of your photo of your dinner party, and that just doesn't look right. It looks like the same, in this case, the same protein band visible twice in a photo. So that is what I'm looking for.
It seems incredible to me that as an outsider, that anyone can even contemplate doing this kind of image manipulation. Why do you think? Why do you think? I know this is a tough question, but why do you think it? Why do you think it takes place?
Because I assume that people do it because then the results look better. So scientists might do an experiment. They might have a very firm hypothesis. They think they have an idea how a particular molecular pathway works or whatever, and they do their experiment, and now the outcome is not as nice, or maybe it looks okay, but the blot, that Western blot, looks smudged, or there's a crack or a hair, and maybe they just try to Photoshop the crack or the hair away. They try to beautify it, or they might actually try to make the experiment look a little bit better than it actually was. Because if an experiment looks good, it's easier to publish it. And if it looks really good experiment, you can even publish it in a high impact factor journal. And that is very good for one's career. So photoshopping in the end will enhance your career, and just to make some shortcuts there. But so it's tempting to do it, because it is possible. In the digital age, you can actually easily Photoshop your experiments. And in the olden days, you brought your blots, that Western blot, you brought to the photographer in the basement, like I did. But now you can just take a photo with your cell phone and Photoshop at home, and it's very easy. And who will ever find out? Well, sometimes I will find out about it.
Gosh, so so you think it's really sort of publish or perish? That's true. This kind of this drive to get published. Gosh, so when you started finding this, you were finding these examples by hand, I assume. So, but the articles containing Western blot images, there must be thousands of them, I guess. So this must have been like looking for a needle in a haystack.
Yeah, but I will. In my searches, I will search specifically for Western blots. That is how I started doing it. So I found that problem in that first paper or PhD thesis that I found, that was a Western blot. So I thought, okay, let's just do a search in a biomedical journal, and I'll search for the term Western blot and see what comes up. And so I opened the first 100 papers, and I just screened for the images. I didn't read the articles. I just flipped quickly through them, comparing the images to each other within a paper. And I found already that first evening a couple of other of those duplicated examples. And we call them inappropriate duplication, because sometimes it is quite okay to duplicate an image and if it represents the same experiment, but if it doesn't, then you need to you expect to see a different photo if it's a different experiment. But so looking for these inappropriate duplications, I found several other examples. And so if you stick to molecular biology papers, you're not only going to find photos of Western blots, but there will usually also be photos of tissues, or like microscopic photos, where people compare tissues with antibodies, seeing the expression of a particular protein in the setting of a whole tissue. Like, is it only expressed at the edge of the tissue, or only in those little structures you see there? And so you see fluorescent microscopy photo, light microscopy photos, slices of tissues being stained with antibodies. All kinds of photos, and I found also problems in those photos. So basically, I was looking for photos. Like if it's just a line graph or some plot, I usually cannot say much about it. But photos, they might show signs of manipulation. So that is what I focus on.
So you got to the point where the scale of this was increasing. Of course, the next question is what sort of proportion of papers did you find had this word inappropriate, which is quite a neutral term?
Well, yeah, I mean, you could call it fraudulent, or you could call it erroneous or so. But like we thought inappropriate was good. We didn't want to get sued, of course. So and some of these might be errors. But yeah, I had exactly that same question. That first evening when I found that duplication in that PhD thesis, I thought, how often would this happen? Like, is this, if you open 100 papers, how many would have those problems? So in that first 100 papers that I opened, I found, I think, 2 or 3 or so. But yeah, 100 is maybe statistically not very strong. So let's do 1,000. And then in the end, I scanned 20,000 papers. I'm slightly crazy. But again, I only looked at the images. And this took place over about 2 years. So it was my hobby in the evening. I was still employed doing my microbiome research at Stanford. And scanning 20,000 papers from different journals. And I found 4%, 3.8 to be exact, 4% of these papers to contain these duplications, inappropriate duplications within the papers.
Gosh.
And yeah, so it's 1 in 25, and so that is quite more than I thought. And some of these are errors. You can imagine that if you are a researcher and you take hundreds of photos of all kinds of things, think about if you're on vacation, you go to a lovely island and you see 4 different sunsets in your vacation, and you take all kinds of photos. But and you take photos that are slightly shifted. You can imagine that some of these photos might overlap. But if you say this was beach number A in one photo and beach number B, a different beach in a different photo, they might overlap. But you still see the same pulp tree, for example, in the same photo. So basically, you might end up with photos that are shifted. So you take hundreds of photos of tissues. And then some of these overlap because you move your sample under the microscope a little bit, and think, okay, this is the best photo, and maybe by accident you grab the wrong photo twice. And you use it to represent a different experiment. So some of these are errors, some of these are intentional. When a photo is rotated, flipped, etc., we assume it's intentional. When a photo is photoshopped, where you say that same Western blot band multiple times in the same photo, or you see the same cell 100 times in one photo that looks like it was photoshopped. Yeah, that is when we assume it was done with the intention to mislead.
So whether deliberate or not, nonetheless, it's an incredibly high proportion, 3.8%, because I don't have the figures in front of me, but the proportion of papers that are retracted each year are still much, much lower than that. So are you suggesting that the scale of the problem is larger than perhaps we estimate currently?
Yes, very likely, because most of the papers that I found, and I reported them to the journal editors, they were not retracted. Now, in some cases, like I said, there are honest errors. There might be two photos that overlap, or by accident the same photo was inserted twice, and it might just be an accident. So some cases, retractions is not the correct answer. It would be a correction, or an erratum, or whatever the journal wants to call it. So that's quite okay. But so maybe half of these 4%, so 2% might be a retraction worthy. But unfortunately, most of the journals didn't really do much, especially the first 5 years, and that was frustrated. So after 5 years, only 1/3 had received a correction or a retraction. And now, over a much longer period of time, I've probably scanned, 200,000 papers. I don't even know, I don't keep track, but hundreds of thousands of papers. And I found roughly 6,000 with image problems instead of the 800 that I found first. So the scale has gone up. It's probably around 200,000 that I scan now. And so it's still sad that in most cases nothing seems to happen. And that is just sad. But I agree that it's many more papers need to be retracted. And I also think that the scale at which misconduct is happening is very quickly and suddenly, no, maybe not suddenly, but definitely more recently on the rise. So there's many papers that should not have been published in the first place.
Well, one of the things that has changed in the external environment is the whole concept. The phrase research integrity, I shouldn't imagine existed when you started looking for these errors.
I think it already existed, but I think it wasn't really known on the wide scale that it is. Hopefully now that people are more aware with it. There has been quite some attention in the general news sites on misconduct. There have been a couple of bigger cases at Harvard and Stanford, and that were in the news, and so I think it's more known to the general audience. For better or for worse, but yeah, I guess you can say there's fraud everywhere. There's fraud in banking and construction, and there's also fraud in science. So it's just happening. It's just a part of what humans are. Some people do fraud.
Yes, but as you mentioned, I think you yourself noticed that it would appear that do you think it's increasing, or it's just more noticed?
It's a combination of both, but I do think it's increasing because there are certain countries that are pushing their researchers to publish more. There are certain universities that are doing the same. I think on all levels, we feel as scientists the pressure to publish. The publish or perish culture is increasingly there. I think, when I did my PhD, a researcher was quite happy when their paper just got accepted in a journal, and now it needs to be Science or Nature. And if you hear about these faculty searches where only candidates are considered who have published at least 2 papers in Nature or Science,
oh gosh,
man, we're really raising the bar here. And if you raise the bar, then people are going to find all kinds of means to reach that goal. But also I think we've seen a huge influx of people from non-traditional scientific publishing countries, let's say non-North American or non-North European, who are looking to find ways to get published and to perhaps move to those countries. They're really hoping for a postdoc in a European or North American country. And you cannot blame them, because maybe in their country there's not a lot of money available for science, not a lot of they cannot buy very expensive equipment, or so they can only do maybe simple types of research that don't cost a lot of money, but they're frustrated and they really want to do better work, and so maybe they're looking for ways to make their resume look a little bit better, and they see these advertisements for what we call paper mills. These are networks of scammy people who are selling fake papers to people who love to be an author on a paper. And so I think there's in the past, I'm going to say 15 years or so, a huge increase of these fake papers being published. They're probably completely fake. They might contain photos, and they might contain data that looks real, or they might just be review papers or fluffy systematic reviews. But these different paper mills use different templates and different techniques. They might plagiarize. They might use AI even to plagiarize. And they just churn out papers after papers. And I do think we have now a tsunami of papers that are completely fake. And that is incredibly on the rise. And I think with the introduction of AI to the general public, it's opened all kinds of floodgates to be able to write your own fake paper. So yes, it's tremendously on the rise. But also we're detecting more. We're more aware of it. But yeah.
Well, in some ways, we haven't even moved on to the most sort of challenging part of it, because I think we can understand why this happens, and we can understand how to detect it. But actually, how it should be dealt with, I think, is an even more challenging question. So at the moment, the scholarly publishing industry seems to be dealing with integrity by kind of self-policing. Do you think that's sufficient?
No, clearly there's too much that still falls through the cracks, that passes all the filters. I feel we need to have a maybe countrywide or worldwide Office of Research Integrity that can investigate cases, because very often there's all kinds of conflicts of interest. Imagine you're an editor and somebody writes to you saying, well, that paper has been, that's all falsified data. Can you look at it? But the author of that paper is the person you just had a lovely beer with at the conference, right? I mean, in some research fields, everybody knows each other, and it's hard to believe that a person did something bad because you know each other. You're best buddies, or you just published together. Or let's say an institution, a big name research university receives complaints about papers from their biggest star professor who gets lots of grants and lots of publishing. And really, because of that professor, the university ends up much higher in the rankings because there's this one person who's very productive. And now suddenly they find misconduct. You can imagine that there's all kinds of conflicts of interest. Do we want to admit that this person is not very good, and then we will end up much lower in the rankings next year? I think a university loves the rankings. We all love metrics, and because we love metrics, people are going to cheat. So maybe we need some international, more independent kind of organization or body looking at it. Self-policing definitely is not working. And one of the metaphors or analogies that you can think of is that of sports and doping. Like in sports, there was this time, and think about the Tour de France and maybe also the Olympics, where it wasn't about the best athlete; it was about who used the most doping to win the race.
Yes,
and so are we? Is self-policing good? Like we ask everybody to sign a document that they didn't cheat or didn't use doping. It's not going to work, because if you're an athlete and you want to win the race and you see everybody winning the race using all kinds of drugs, you're also you have to participate in that rat race. And so at some point somebody decided, or the whole sports decided, let's start policing for this. Let's start checking for doping, and if you use doping, you lose your medal or you're not going to win. And so this is what happened in sports. But I think in science we're not at that point yet. We're all seeing there's a problem, but we're gonna do some light punishments. But I think we need to have much more strict consequences for people who get caught using doping, using fabrication.
I agree, but I think unfortunately, as an outsider, my perception is there almost seems to be we're still in a situation where people are kind of passing the buck. So there was a recent article by a scholarly society publisher who claimed that society should not be burdened with the additional expenditure of checking articles because they didn't have the money. Well, if they didn't, who could? Who should?
It's a tough situation. I think for larger publishers, think about the big scientific publishers, there's a lot of money there. So you can definitely ask them, to do quality control and to do recalls. Like we have, you buy a car and the wheel falls off or the airbag is faulty. We expect that that quality control is with the manufacturer. But then a publisher can say, well, we're not the manufacturer, we're just the dealer. But who's the manufacturer? Maybe the institution. So in the end, maybe it should be the institutions. But like I said, in several cases, it might be that the institution is also in the loop, or they don't really want to police because this is the professor who brings in all that lovely grant money and actually gets the whole university running. So the university is not going to police. And I do think that publishers are still the gatekeepers of science. And that is, if you read several publishers' statements, a mission statement, that's what they add. They claim to add something to science. But I'm also sympathetic for the more smallish society publishers who are, running on much less money than the big publishers and who are a more smaller group. But I think we might not see a lot of misconduct in those society journals because very often those are smaller communities. But if you see art, it doesn't seem to cost much. Like I'm running this with just a monitor and a computer and an internet. Like I can see it doesn't cost that much money. And maybe, but yeah, it does need to. I'm not sure who needs to do it. I think in the end, everybody involved needs to pull their part. But I think when a sleuth like me comes to a publisher and says, this is photoshopped and here's my
evidence.
My evidence, you don't need to do a lot of, like, if I bring you good stuff, like this is what I do for free for you, just retract the paper. And apparently that doesn't seem to cost that much money, but I of course see things from my perspective and not that from the publisher.
Of course. Do you think there's a role for libraries in providing guidance or managing research integrity? Absolutely.
I think just telling people that there's, don't trust all the papers because there's some bad stuff in there. I think libraries have been doing that, but I think they need to be aware and need to educate their students and their users, their clients, on that bad, paper mills exist, fraud exists. If you read a paper stating something, always have that little voice inside your head. And is this real or is it fake? Even though a paper has been peer-reviewed and published and it has this peer-review stamp on it, it doesn't mean it's correct. Science is a movement. We're always searching for the truth. We're never getting there. And we always publish science and read science with a particular mindset of we want to believe that smoking is bad for you. And I think we figure out it is. But we
do now.
We do now. But look, if you read papers from older papers, there were all kinds of conflicts of interest and different insights. And, is COVID airborne or not? I think this is a great example where in those first months or year of the pandemic, there was all this research. And one researcher said, oh, no, it's not, it's only in like bigger droplets or smaller droplets. And it became very technical. And it just shows you how difficult science is, that it takes... You cannot just do one experiment and know the truth. It needs repetitive experiments that all look at the process in a slightly different way. And then you'll finally reach an answer. And maybe we'll never reach that answer. But there's in the beginning of a science topic, there will be many seemingly conflicting results. And I think that is very confusing. And you definitely can find papers that will tell you that smoking is really good for you. But see it in that perspective. Yes,
even today. You mentioned AI is sort of in a negative light, but presumably there are AI tools that can help the kind of work. I mean, you did heroic efforts to find things by hand. Are there AI tools that help you to do this kind of thing?
Absolutely, yeah. So I'm, in the beginning, that 20,000 papers set that I scanned, I did that by hand, by eye, I guess. I just look at them and probably missed a lot. But now I'm using AI tools. At least they're partially based on AI. It's basically, I'm using Image Twin or Proofig, and both of them are partially AI based. And I'm not a computer scientist. For me, it's a really handy tool where you can drag and drop your PDF that I'm investigating, and it will look for images, and it will also sometimes find papers or images that have been used in other papers. So not just in the paper itself, but they're building up libraries, these tools, of images from other papers, and it will say, oh, not only is this image in this paper, we found the exact same photo in a different paper. And I could never do that as a human. We cannot store. I don't have a photographic memory. I can remember a Western blot for 5 minutes or so, but I cannot remember millions of Western blots, especially if they don't have that little dot in the top right corner to help me recognize it. So it's been very helpful to help me find more of these examples.
Well, that sounds encouraging. But in terms of the problem becoming even larger, the rise of preprints, of course, means that the problem is exacerbated, because preprints go through very few, if any, checks before they're placed on the preprint server, and frequently they're treated as if they're peer-reviewed and authoritative. Yes,
and I would have to say I love previews. I think it's a very fast way to show results. And now we can actually use preprints and then publish it later. But I think for the general audience, it is hard to really know the difference. Even if you put a little stamp on it, not peer-reviewed, people have particular political motives or who want to bring out false narratives, could upload false data and then just claim, oh, well, it's peer-reviewed, here it is. And I've seen that, especially since PubMed is now including some of the preprints, and so it's on PubMed, so it's peer reviewed. I think it's really hard to explain. If people want to push a false narrative, they're going to do that. Having said all of that, I've seen very little problems with photoshopping or fake papers in preprints, and I think it is because the scammers know that once a paper is on a preprint server, there's many more eyes on these articles than just two peer reviewers and an editor. So the people who want to push out the false narratives, the fake AI-generated text or review papers, those are deliberately putting it. I think that's my hypothesis, but this is what we're seeing. We don't see these generally on preprints. We see them being published because they know once it's published, it's published. Like they can tick that box on their resume. Nobody's going to check if the paper is retracted or not. They can just put it on their resume and have a better career. And so they're because they know it's only going to be seen by 3 people. And if one of the peer reviewers or the editor catches them, this is AI generated, or this image is clearly stolen, or this data cannot be real, it's all fake. They just move on to the next journal, and eventually they'll find a home for it. I've seen cases where peer reviewers said, well, I rejected this paper because it was clearly fake. And now I see it being published in a different journal. And, they're going to find a home for it. But in a peer review, in a preprint article, there's not just 3 pairs of eyes on it or 4 pairs. It's thousands of pairs immediate. And so somebody's going to raise. And you're right, there's a very light peer review. I think there's some moderation in archive or medRxiv to make sure, not in archive, but in bioRxiv and in medRxiv, there is moderation to make sure it's not, let's say, a racist rant or something like that. So they do,
cancer.
Something impossible. So they do check, they do some light moderation on it. But when if I would find misconduct, I think they really quickly take it down. So there's
Well, that's remarkable, because what you're saying, in effect, is, and it doesn't often happen like this, the sort of a change in the whole sort of system of scholarly publishing could actually lead to some benefits, maybe unexpected, unanticipated, but nonetheless benefits in tidying up the whole publishing situation.
Yeah, and I think in general preprints are great, and I'm always thinking how big of a change that is in scientific publishing. If I think when I did my PhD, and we're talking, mid 90s here, like a long time ago, it was unheard of that you could publish your results before you send it to a publisher. Like I was told, if you even talk about this research on a even if you have a poster on a conference, it's unpublishable now, and that has changed so much. Preprints are an enormous change. In the beginning, everybody was nervous: is it still publishable? But it can actually improve your papers. I've talked to people who found it very hard to publish a particular research because everybody thought it was crap and nobody believed in it, and they put it on a preprint and then found that everybody was talking on it on Twitter or on social media. And now the publishers were fighting for it. They all want to publish because they know it's going to cite a lot of reference. And so, and this is actually also what I did with my paper on scanning 20,000 papers. It got rejected, I think, 4 or 5 times. Nobody wanted to publish it. They all said, this cannot be true. There cannot be a woman who scans 20,000 papers and finds these papers. And even though I had 2 co-authors who had to agree with me, like I set it up, like nobody believed me. And so I'm like, but I really did this. Why don't you believe that I scanned 20,000 papers? Like, that is not that crazy. Maybe they thought it was crazy. But in the end, we put it on a preprint. We worked with Retraction Watch. And then suddenly it was a little bit easier to publish it. So, yeah, it's a strategy if you use it well.
Well, that's an encouraging story. Yeah. Can I go into another area, which is perhaps even more fundamental than image manipulation? This year's Charleston conference, Andrew Ballas spoke about this, but in fact there have been many others who talk about it, which is some of the sort of less palatable aspects of science publishing. For example, the way that many more medical trials take place than are ever published, and negative results are often not published. Do you think there's a solution to that problem?
People have worked on that, and it would be called it's called pre-registration, where and I think this is a really good development. So basically, it means that if you are going to run a clinical trial, you registered on clinicaltrial.gov, I believe, or org or something like that, and you promise basically to publish it. Now, that doesn't always happen, but at least it's registered. Like, okay, we did this study, so many patients, we're going to test this. These are the endpoints we're going to check for, primary endpoints. Second, like, let's say we're going to test people who have used our drug for 5 months and then at 10 months and then at 15 months or something like that. And then you hopefully will publish this. Even if the results turn out to be negative. Because I completely agree, it's such a waste of time if people are reinventing the wheel over and over again and not publishing. And it's especially with clinical trials, I would say you almost have an ethical duty to publish it because you're recruiting patients, you're giving patients hope, maybe false hope, but you give them hope. And you, just for the sake of all these patients who participated in your study, you have an obligation to publish it. So negative results deserve to be published. Now, of course, it's much harder, at least in the publishing world, to publish these results. So more and more journals are saying, no, we should also publish negative results, especially when it's clinical trials involving, recruiting patients and testing them. And so I hope to see more of that. But even with biology, more preclinical work, I feel when you use animals or so, also you feel you should have an ethical obligation to publish the results. So I hope to see more of that. We need more negative results to just know what is better, because otherwise, if we only publish positive results, we're going to have this fake idea that particular things work, and we might not end with the right conclusion that maybe it doesn't work or it only works a little bit if we cannot count those negative results because they were never published. So I hope with pre-registration on these sites, on clinicaltrials.gov or whatever, we can have at least these trials published.
Mm. So, to sum up, would you say you were optimistic? It seems unusual to sort of think of optimism for somebody who's discovered such a sort of enormous number of issues.
Depends on the day, because sometimes I'm also very pessimistic, because I do think with AI it can do wonderful things, but I'm very worried about what it can do to create fake science. And so we've seen these paper mills, we've seen that are tremendously on the rise. I think we don't even know how much they're on the rise, because they're getting so good that we cannot catch them. In the beginning, they made all these weird mistakes, like publishing papers that said that half of the prostate cancer patients in their trial were women, and you can catch them on mistakes like that. But it's all made up, and I think they're still publishing. They're just getting better at it, so we cannot. There's no golden nugget for us to find. So AI can tremendously help people, the bad people, to create even more fake papers. It cannot just create a fake text, but it can create fake data and fake images, fake bar graphs, but very realistic photos. And I don't think we can distinguish them from each other. So I think we have no idea how much fake paper there are right now. There's probably much more than we think. And so I'm pessimistic about that, because it's so easy to use, and it's if you are that postdoc or that medical student who wants to enrich their career or enhance their career, get better, it's very tempting to use it. And or if you're a little bit more of a computer programmer and you know a little bit better on how to develop your own machine learning generative AI tool, you can just produce fake Western blot or fake microscopy photo after another and sell them to people who want to publish fake papers. So very worried about that, very worried about we no longer being able to distinguish fake from real. So I'm very pessimistic in that respect. And maybe we need to think more about what we just talked about, reproducibility. Maybe we need to think more about ways where we do smaller experiments and where we can only know that they're real if other people were able to reproduce them. And I think that might be a very different way of scientific publishing than we've done in the past 50 years. Maybe we need to move on to a more micro-publishing model where we can try to reproduce each other's papers. And because that's maybe the only way we know that a paper is real, if we can reproduce it.
Well, you made some very interesting suggestions for how the scholarly community can go forward and police itself. I'd love to think that maybe we could talk in a year's time and see that sort of progress has been made and come back and sort of see what's happening.
Or maybe it's very pessimistic and all the papers now are fake. But
oh gosh,
let's hope not.
No, let's hope not. Anyway, Elisabeth, many thanks for your time. I'm astonished that sort of 20,000 papers sort of heroic to sort of to achieve that. But I think the work that you've done has actually been fundamental in demonstrating without any doubt the sort of what goes on and what and I think without your work it would there wouldn't have been anything like the awareness of kind of misconduct in science. So thanks for all your work, and thank you for talking to us today.
My pleasure, Michael. Yeah.
And look forward to sort of maybe meeting you at another conference, and perhaps with fingers crossed, hoping that sort of there have been some new initiatives. Thank you very much.
Great talking to you, Michael. Bye bye.
Thank you.